Hello, welcome to this new explainer. The explainer is about the most famous student in statistics. And I'm talking about William Gossett. Why is he student? Well, he used the pseudonym of student in his statistical papers. And as usual, I've got questions for you, but beware that this explainer is much shorter than the usual explainers, because the step-by-step guide this week is longer than usual, and it explains how to run the t-tests, which are very crucial for your assignment. And so I spend a lot more time in there, and also to give some time to an explainer that is concentrating in the research report. So it's the second part of writing a research report video that started in week 1, was published in week 1, and now there is a second part. Okay, so the first question for this explainer: is Guinness the best beer? Okay, if you didn't see the masterclass, you're probably asking why I'm asking this question. But William Gossett worked in Guinness, and he was studying the properties of barley to grow good quality barley and to have good quality beer. And that's because of his needs to do research with relatively small samples, and not being able to, because you don't have the resources to conduct many replications of the same experiment. And he found that there was huge variability within the types of barley. So he compared one type of barley to another type of barley, and what he found, yes, there were differences between these two types, but there were differences within the types. So differences in quality. So he developed a test that took into account, so to test whether there were differences between the two types of barley. He devised a test to take into account the variability within each type. Okay, so I now have the real questions. So first question: why is it useful to use the t-test and not the statistic of interest? So basically, I'm referring here to the statistic of interest. In this case is the difference between means in two independent samples. Okay, so in the case of Gossett, he had a group of one type of barley. So the idea is to grow barley, and then you measure some trait that it's a proxy for the quality. Perhaps the quality is measured by tasting it, I don't know, but height may be one important trait. So you've got one type of barley and another type of barley, and so you measure the height of all the barleys, and then you calculate the mean for each of these types. And then you calculate the difference between these two means. So that's the statistic of interest, the difference between these two means, or the mean difference. And so why do we have to use a t-test instead of using directly this statistic? So that's the first question. The second question is, what is the p-value? And we went through this before in the Fisher lecture, so this is a refreshment, because the concept of p-value is very important. So important that since Fisher is being used almost uncritically in loads of sciences, and including social sciences and psychology. But last year, the association the American Association of Statistics recommended not to use statistical significance anymore. So we need to know why. We need to know what's the p-value and what are the problems. So researchers, and until recently, even though there were critics of the p-value for a long time, but most researchers, they don't know what the p-value is. They have a wrong conception of what the p-value is, and they just report. They know that it has to be lower than 0.05 in order to be a significant result, and that's it. And because we don't know that concept very well, researchers didn't know that concept very well, they made a lot of mistakes in their research. So much that the American Society of Statistics is now recommending eliminating the statistical significance. The third question is, what are the components of the t-test? And the fourth, in what occasions the independent samples t-test is used. Okay, so let's start with the first question. Why do we use a t-test and why not the statistic of interest, which is the difference between two means? Well, let's say the mean that we are in, the scale we are using to measure is one that goes from 20 to 80, and so we've got a mean of 60 in one group, a mean of 50 in the other group. I do the mean difference is 10. And if I use a method that allows me to see if that value of 10 has any significance, it's not going to help for a situation in which I have a scale that goes from 0 to 1, or is measured in very small values, or is measured in, let's say, in dollars, thousands of dollars. The difference will be much lower or much higher, and the same method that I used for determining whether 10 is a significant difference between these two means, it won't help to determine whether there is a significant difference between other two means that use different scales. The t-test is useful for any scale you use of measurement. Why? Because you transform the raw score into a t-score, and the t-score is similar to the z-score. So that's the reason why we use a t-score instead of a t-test, instead of dealing with the statistic of interest directly. Now, there is another reason. This was needed, it was very important to do when computers were not powerful, or in the times that these tests were developed, there were no computers. So basically what Gosset and Fisher and Pearson, what they did is to develop distributions that help in many situations, and then they created tables to determine what's the probability of observing a specific value in that distribution. So researchers that were not knowledgeable of statistics, then they went to books in which those tables were published, and they used that to determine the probability of observing a value in that distribution. So can you imagine that if you do that for any scale you use, a scale that goes from 20 to 80, another one that goes from 100 to 350, if you have to do one for each measurement you use, those tables would be impossible. So there would be an infinite number of tables. So that is important. Now, today we can do, and which is because and I am anticipating one of the other answers, is we use sampling distribution. We need to generate a sampling distribution. Now, what Gosset and others did is they developed those distributions, but generic ones. Today, we can develop a sampling distribution in seconds or even milliseconds, and just running a line of code or 2 lines of code. So it's very simple because we have very powerful computers, so we can actually, if we wanted, to develop a sampling distribution of the statistic of interest directly. So, in a sense, we don't need the t-test anymore, but because we are talking about simple things here, but then the t-test is used for more complex things, and perhaps in those situations it's important to keep the generality of the test instead of going to use measures. And also it allows to compare, okay, if I've got a t-test of certain value here, how does this compare with another study? Well, if you use the original scales, there's not a good comparison, but a t-test in one study compares to a t-test in another study that they use other measures, so they give you an idea. Although this is disputed, but I'm not going to go into that detail. So that's the reason we use t-tests, because it's more generic than the specific statistic of interest. So the second question was about what's the p-value. So the p-value comes from a distribution. What distribution? A sampling distribution. What is a sampling distribution? Well, for a sampling distribution, to create a sampling distribution, we need to imagine that there exists a population of values, and then we again imagine that, or we use this entity, the probability demon. So you imagine that there is such an entity that does this for us, and we extract samples from that population. Okay, so those samples, what characteristics should have? Well, they have to have the same sample size as the one that we use in our study. Well, why do we do that? Well, because we want to compare our study to what would happen if this study that we conducted is run infinite number of times. Why do we do that? Well, Fisher taught us to do that. Remembering the case of the tea, that he wanted to test whether this lady was capable of differentiating between the two types of serving the tea. And so what he imagined is that what happens if someone who doesn't have any knowledge does this task? Well, by chance, that person could get it right once in a number of times. So that's the sampling distribution that we want to generate here. A sampling distribution that would mimic the idea of from a population in which there is no differences. So the mean difference in that population, so imagine that population has values, half of those values we give the label A and the other half label B, but they are attached to numbers. And the mean difference between the value of the values A and the values B, the mean difference is 0. So when we start extracting samples and we calculate the mean difference from that population, well, most samples the value will be close to 0, because we come from a population in which the difference between these two values is 0. So, the difference between the means of these values is 0. So we expect that our samples would be 0, but it could be a bit more, a bit less, a bit more. Well, how much more, how much less? Well, that's what the distribution, the sampling distribution is. We simulate that, we do this thousands of times, and we create a distribution of the values we obtained. And so basically this will show us by if someone runs an experiment thousands of times from a population in which there is no difference, what's the probability of finding different types of mean differences? And well, so we do that with our study. So we've got a population of 2 types of barley and with different heights. But when we calculate in that population, when we calculate the mean and we calculate the difference between these 2 means, the difference is 0. Okay, so we start with a population in which the difference is 0. We extract samples of the size of the sample we extracted, but so we've got, in this case, there were 8 of one type and 8 of another type. We calculate the mean of that sample, small sample, and we calculate the mean difference, and we do that thousands of times. Therefore, we've got a huge number, thousands of mean differences. And again, these mean differences come from a population in which the difference is 0. So we can generate a distribution of that, and it will look like something like this. Well, it will look like this if we use a standardized score, which is the t-score. And I'm going to explain in another answer the components of the t-test. So, but basically, this will tell us what's the probability of finding the value that we found in our study. So, if we obtain a t-score of 1, we have to look whether what's the probability of obtaining that one, or more extreme. That's the p-value. The more extreme is so important. If our hypothesis is that the 2 means are different, we don't know whether they are higher, one is higher than the other or not. So our hypothesis is that the means are just different. Then we need to look at the 2 sides of the distribution. So if we have a t-score of 1, then we have to look at the area under this curve from 1 to infinity, and we have to look at the area under the curve from -1 to infinity. So that probability, I don't know exactly, but it should be around 40% or a bit less, but it's quite large. So still it's good probability that the sample we obtain comes from a population in which there are no differences. But if the t-score we obtain is 4, for example, so we need to look at the area under the curve from 4 to the right and from -4 to the left. Well, you can see that there is almost nothing. It's almost 0. It's not exactly 0 because this distribution goes from -infinity to infinity, but it's so close to 0 that is negligible. So we've got that if we obtain a t-score of 4, it is very unlikely that comes from that population. And if it is very unlikely, we decide that it doesn't come from that population. So we decide that the difference that we observe in our sample, they are significant. It's not just by chance that we obtain that difference. Okay, so that's corresponding to the p-value. Third question is, what are the components of the t-test? And these are the components of the t-test. So the t-test has, the first component is the mean difference in the sample. So you calculate the mean of group A, the mean of group B. This could be a group A, could be control, and group B experimental, or it could be a non-experimental study in which we compare males to females, or it could be two different conditions. Yeah, it's experimental, but we don't have a control and an experimental group. So there you have two different conditions. You ask a group of participants to perform a memory task with information presented with images, and in another one information presented in text. So two conditions, there is no control and experimental, but if you assign participants to groups in a random fashion, then it is an experiment. Okay, so anyway, the t-test is agnostic about how you conducted the study. So there are two components: how you conducted the study, the design. It's important because it allows you to determine whether there is a causal relationship between the variables. The t-test is agnostic about that. The t-test will tell you, well, the difference you found is significant or not, but it won't tell you whether there is a causal relationship. So, and that you get by doing an experimental design. Okay, so that's the first component, the mean difference in the sample. The second component is the mean difference in a population in which the null hypothesis is true. So the null hypothesis says that there are no differences between means in the population. So if there is no difference, the mean difference in the population in which the null hypothesis is true is 0. So basically, we've got this MD in sample is the mean difference we obtain in our study, and MD in population in which the null hypothesis is true is 0. Now, it doesn't have to be 0, because we may want to test that against a population in which the mean difference is 2. I don't know. Typically it's 0. Most of the times, like 95% of the studies will test against that the difference is 0. But theoretically we can use it. We can choose any value. The third component is the estimated sampling error. The estimated sampling error is the distribution I told you about. The generating a sampling distribution of mean differences. So not t at this stage, but at the mean difference. So if we obtain a sampling distribution of mean differences, so from a population of the null hypothesis, we obtain samples, we obtain the mean difference in each of these samples, and with these mean differences we've got the distribution, as I showed you. Well, what's the standard deviation in that distribution? That's what we want to know. So that's what is called estimated sampling error. So these are the three components of the t-test. The final question is in which occasions we use the t-test. Well, we need to have two samples. Sorry, the question was specific to the independent samples t-test. We are going to see the dependent samples t-test in another lecture. So the independent samples t-test, it requires that you have two independent samples. So what are the independent samples? Well, what I exemplified just now, the two types of barley, these are two independent samples. It could be a sample that I collect a sample in males and another one in females. I collect a sample in a group of people that I ask them to do a task, and a task under some conditions, and another group that I asked them to do a task, the same task, but under other conditions. It could be two different cultures. I give them a test and I want to compare the two different cultures. It could be a study in which I have a control group and an experimental group. So what we need is crucial is that we have two samples that are independent. So what would be dependent? Dependent would be if these two samples, they have some relationship. For example, if I'm a participant in a study, and I am asked to do a task under one condition, and myself is asked to also do the same task under another condition. So I contributed 2 scores. And other people will contribute also 2 scores. So you've got a sample of people who contributed 2 scores. Now those 2 samples are related. They are not independent. Why are they not independent? Well, because they are associated. The same person contributed 2 scores, right? So that would be dependent. When you have these type of studies, you don't use the independent samples t-test. You are going to use the associated samples t-test, which has the same components as this one. So not the same, similar components. We have some measure of difference, which would be a bit different, and we have a measure of the difference in the population, and then a standard error or an estimated measurement of error, of sampling error. So this is what we need in independent samples t-test. So I'm just giving you some examples. Okay, of course, a more general aspect. The independent variable has to be categorical or nominal and with 2 values. So that's what I explained. The independent variable would be a condition, 2 possible values, A and B. Group, male, female. Culture, Australian, non-Australian. So these are, the independent variable is always has this characteristic. It needs to have 2 values. The dependent variable should be numeric. If the dependent variable is not numeric, you cannot use the t-test. So we need one, and now I'm giving you types of situations in which you can use. As I explained before, control group versus experimental group. And that is the one that you have to use in your assignment. In your research report, you have to have a control group and an experimental group. So this is essential for your study. Group A and group B. So not necessarily here is not experimental. We've got a group A and group B, and the groups were there before. I couldn't assign people randomly to the groups. Whereas in the control group versus experimental group, I assign people randomly to these 2 groups. And another version is condition A, condition B. And this could be done experimentally or not. Like for example, in the winch study of participants, well, people were assigned to one condition of training, memory training, and another condition which was doing arithmetic, and that wasn't randomly allocated. It was balanced. It was used some measurement was used to put participants into 2 different groups, but it wasn't randomly allocated. So if it is not randomly allocated, we don't call it experiment. But it could be randomly allocated. I can allocate participants to 2 different conditions, and I do the allocation randomly. So that is a possibility as well. And these are the typical situations in which we use the independent samples t-test. There are many others, but these three are the most important.